I hope everyone is doing safe and well there. The first few slides are just going to cover the actual APs themselves because we've added quite a few new models to the lineup. So I'll just briefly go over that. I won't cover all the specs because we all know the specs and we can all get the specs from the data sheet. But I'll just highlight some important points on each of these access points and how they compare to each other. And then once we finish all of the product related items, we'll talk more about wireless itself, some wireless fundamentals, as well as some troubleshooting tips and tools that will help everyone along with their journey in Wi-Fi, and it'll help your customers and provide a faster resolution time if there are issues that do come up. So I think that's the most important thing, is making sure that things are fixed very quickly when they do happen, especially in the wireless and networking world. Okay. And one of the reasons why I wanted to spend some time today on the GWN series is because through this whole pandemic, the whole world is changing. Obviously, there are some product lines that are more relevant today than ever before. And aside from the video conferencing and the remote work type items, the wireless networking has been a huge, has been hugely popular for us in the portfolios that we provide, and we see that this portfolio growing, even as some of the traditional products have been slowing down a little bit. So I think it's good for everyone to get reacquainted with this product lineup, and hopefully you guys will learn something new today, at least one new thing, and my goal would have been achieved today. Now, at the end of this session today, there is a short quiz on the topic some of the items that we're going to be discussing today. So pay attention, take notes, and we'll get started. And throughout the session today, if you have any questions, feel free to either actually, you can't unmute yourself, but type it in the chat box on the bottom there, and I'll try to answer them as we go along. Okay. And again, we'll get started. And the first portion is going to be a review for everybody, so I'll just breeze through it really quickly. Feel free to ask questions. Okay. So the reason why I have this slide up, although I know that everyone knows what the GWN series is, I want to point out in this slide, and in a lot of our slides, you do see that black box in the middle, which is the GWN 7000, which is our gigabit VPN router. Now, I bring that up because although it is still currently part of the portfolio and is still relevant in certain scenarios, I want to emphasize that it is not a product that we will be developing further in the future. Everyone that's been here for a little while knows that it started off with very high expectations, and it was really meant to be a very powerful, SMB type router with VPN capabilities. But from the recent firmware changes that you've seen on our website that have been released, it's moving more towards being being its main focus as a access point controller. So you'll see most of the updates on this device on the controller side rather than the router and the VPN server functionality side. So I just wanted to bring that up and then keep that on everyone's minds as we move forward, because that will be the last mention of that device for the rest of this session. Okay. So with Grandstream, as a review, we have two types, technically three types, of access points. We categorize them as indoor access points as well as outdoor access points. What you see here, these 6 devices are our current lineup of indoor access points. And I'll just go through each of these very, very quickly. I guess the most powerful, we'll start with the most powerful access point and go on backwards. The 7630 is our most powerful with the latest and greatest in terms of technology. It is a 802.11 AC Wave 2 device, which we'll cover more into detail later. And it's a 4x4. And we'll cover what that means for those that don't know shortly in the presentation later. But it's a 4x4 with the most wireless throughput at 2.33 gigabits per second. It has a range of 175 meters. And the embedded controller on this access point, keep this in mind, this information might come in handy a little bit later. The embedded controller on this access point can manage up to 50 other GWN access points. The 7615 is also one of our most recent releases. We consider this as the enterprise access point. I would say more on the mid-range, I would say, because it's a 3x3 as compared to the 4x4 on the GWN 7630 that you saw earlier. Other than that, it has a 1.75 gigabits per second throughput, and everything else is the same as the GWN 7630. GWN 7610, which you all know as one of the first access points. Actually, it was the first access point that Grandstream has released. Out of all of our access points, this is the only access point that is not 802.11 AC Wave 2. It's the only access point that is Wave 1. You see that it is a 3x3, but being that it is a Wave 1 device, not a Wave 2 device, it only has single user MIMO as compared to the multi-user MIMO on all of our other access points. The 7605, which is also a new device in our lineup. If you look at the specs, you might guess that this access point is the replacement for the GWN 7600, and you're absolutely correct. It is a 2x2 802.11 AC Wave 2 device with a throughput of 1.27 gigabits per second. Next, you'll see the GWN 7600, which that device is eventually going to replace. Very, very similar specs, except for this 7600 has the capability of managing only 30 other access points in the lineup. So the 7605 will be replacing this model very, very soon. They both currently exist, but this one will go away in the very near future. Now, the 7602, remember when I said that technically we have 3 types of categories for access points? Well, the 7602 I would consider to be a device in its own category because the not only the form factor, but the physical attributes of this access point make it unique. All of the other access points that you've seen earlier are round in shape and meant to be mounted on the ceiling. The GWN 7602 is a much smaller access point, and it's meant to be mounted under a desk or on the side of the wall. Now, when this device was first created, it had a very specific purpose in mind, and that is for hotel rooms. As you can see, it has 4 Ethernet ports, one of it being a gigabit port for the WAN side connection, and 3 fast Ethernet ports built into it to act as a switch. Now, two of those fast Ethernet ports are PSE ports, meaning that they provide PoE output. It was designed for one of those ports to power an IP phone on the desk in the hotel room, and the second PoE port was designed to power up the second IP phone in the bathroom of the hotel phone. But as things have turned out, this device has been a lot more popular than just hotel rooms, but are being deployed in all sorts of scenarios, especially in the work from home scenario. Number one is that a lot of homes, now you guys know better in terms of what happens in India, but at least here in the US and some of the countries that I have experience in, a lot of homes don't necessarily have um, you know, wire drops in every room, and when they do, they're not PoE. And so this device has become very popular in this whole work from home pandemic, where people are bringing their IP phones home from their office, but they don't have PoE switches or enough power ports for their desktop devices. And again, sufficient wireless connection for their whole house. And so this device has been used for that purpose, and seems to be very, very popular these days. Excuse me. Now, this is also a unique device in our lineup because every single access point that we have uh, has a embedded controller on the access point itself, meaning that all of our access points, except for this one, can act as a standalone access point or can be controlled with one of our various other methods, which we'll cover later. Which also means that the GWN7602 is also the only access point that does not have a web interface for you to log into. This device can only act as a slave. Therefore, you have to use a different means for a controller in order to configure and deploy this device. And as of now, you can use GWN Cloud, the GWN Manager software package, or one of the other access points as the local controller for this access point. Now we move on to our outdoor access points, the 7630LR, which is our newest outdoor access point, and the GWN 7600LR, which is our previous outdoor access point. What's exciting about the 7630LR, as you can tell, is it was our first access point that has external antennas. Not only are they external, but they're also replaceable and removable. They do come with omnidirectional antennas that broadcast a signal, but you can also switch out the omnidirectional antennas for directional antennas so that you can get more of a focused signal in a particular direction, if the scenario calls for it. So Akash asked the question, what is the meaning of 3 by 100 megabits wireline speed in the 7602? That's just the speed of each fast Ethernet port. Instead of a gig, it's just 100, but there's 3 of them. Again, 2 of those are PoE output ports so that you can connect your IP phones or whatnot. And we do have an extra one there. That's just basically a switch port, but they're only 100, 10 100 ports instead of gig ports. Now, so again with the antennas, in Wi-Fi there are basically and I say basically because there really are more. But basically, there are two popular types of antennas, and those antennas, you know, the different types of antennas are basically how the antennas transmit their signal, right? For most access points, they will come with what is called an omnidirectional antenna, which means the antennas will broadcast a wireless signal in all directions in a 360-degree fashion. Um, as you can probably tell from the way that the access point looks, uh, a typical installation of an access point with this type of mounting would probably be against the wall, right? So let's say it's against a concrete or a brick wall. All of that space behind the access point and onto the brick wall, it's probably not a good idea to rely on that particular signal because that concrete or the brick wall is going to interfere with that signal. So really only half of that signal would be used, which is the signal in the direction away from that wall. So it's not very efficient, right? And so it's, in that particular scenario, instead of using an omnidirectional antenna, it's better to use what is called a directional antenna, or another name for that would be a Yagi antenna, which focuses the direction of the wireless signal broadcast in a particular direction that you point it to. When you use it that way, you have a more focused signal in a particular direction, which means that signal will be stronger and it will be clearer. Now, with Grandstream, right now we only have omnidirectional antennas. We do not have our own directional antennas, but it uses the industry standard SMA connectors, which means you can connect any third-party antennas to our access point because it shares a standardized connection. Aster asks, is the 7602 wave 1 or wave 2? And the answer is it's wave 2. All of our access points, except for the 7610, is wave 2. Rajesh asked a question, can we use two 7630s as a Wi-Fi extender? Like one can send the signal and the other can receive the signal? Absolutely. All of our devices have the ability to do either bridge mode or mesh mode, right? And so with the bridge mode, you're taking two access points, say in this case two 7630s. You have one 7630 at the main office, and you have another 7630 at a farther location that isn't necessarily wired to the main office. And what you can do is use that wireless signal connection from one access point to the other so that you can connect that remote location to the main network wirelessly. And so in that particular case, though, the access point on the remote side is only acting as a bridge, which means it's only sending and receiving traffic to and from the main access point. Everything else that's on the other side, the remote office, is connected via wired. If you wanted to, in this case, have that second access point in the remote location extend the wireless connection of the main access point, you would use the mesh mode. And you can do that as well. So Ashtir asked, I think I said earlier that the GWN 7602 does not have a web interface. What I mean is that for all of our access points, and I guess all of our devices in general, you're able to log into each device's web interface and do the configuration from there. The 7602 does not have a web interface. meaning you cannot configure the 7602 by itself. So it cannot act as a standalone. Basically, the 7602 can only act as a slave, which means you have to use one of the other methods to control and configure the 7602. The different methods are one, GWN Cloud, which is our cloud-based controller. The other is GWN Manager, which is our software-based controller. Or you can use one of the other access points as the controller for the 7602. But the 7602 cannot be a master, and it does not have a web interface. All right, and Asher wanted me to explain bridge mode and mesh mode again. Let me see if I can do whiteboard, and I will draw this out for you. Now, I do apologize. I'm not an artist by profession, and in fact, I'm a really bad artist. So let's see. This is the main office, right? And let's say you have your warehouse, and they're in a separate building, right? In this particular scenario, the warehouse does not have a wired connection to the main office, but the main office does have that internet connection. And you want that warehouse to be able to use that internet connection from the main office. So one way that you can do it, and let's just say the warehouse has a bunch of wired devices here. It's supposed to be computers. Sorry, and they don't have a wireless laptops. They're just wired computers and wired devices. So obviously, one thing that you can do is you can the color box is weird. Obviously the easiest thing that you can do is run a wire, right, from the main office switch to the warehouse switch. But that's not always possible in a lot of cases, right? And so what the wireless bridge mode does, again, I do apologize for my artwork. And so with the wireless bridge, what you can do is you can have one access point at the main office connected via wire. You can have another access point over the warehouse, and that's connected via wire to the warehouse switch. And then these two will be connected wirelessly to each other. And it's basically creating a wireless bridge, right? So you guys can kind of get the name for that. So that's one way to extend the internet connection from the main office to the warehouse. Now, if the scenario changes a little bit, and let's say, oops, let's say these are all wireless devices, right? However, they're a little bit too far from the from the main office to be able to connect to. Let me just erase this real quick. Sorry. Okay. So let's say this is the scenario. You have your main office, and it does have a wireless access point. And then you have your warehouse that's a little bit farther away. And the warehouse wants to be able to connect wirelessly to this to access point A. However, access point A is just a little bit too far away, right? That's supposed to be an A. Sorry. So one way to extend this wireless signal is to use the mesh mode. And the way that you do that is you have a second access point somewhere in between the warehouse and access point A. And the two access points, obviously, are connected wirelessly. And what the access point B here would do is then rebroadcast this wireless signal out to the rest of the devices. And then these wireless devices at the warehouse are able to connect to access point B, which would then send that signal over to access point A. Cool. I hope that clarifies it for everyone. I see a lot of questions here. Let me try to answer those before we move forward. Rishi asks, how many APs can be handled by GTECH Manager if we install locally? Currently, GTECH Manager can manage up to 3,000 access points per instance. You can install multiple instances. We will cover the system requirements, the hardware system requirements for GTECH Manager in a slide later today. Nitin asks, how many APs can be connected in mesh mode? You can connect up to the maximum amount, but it's not about how many APs can be connected, but how many hops in a mesh environment, right? So for example, in a mesh installation, you have, say, your main access point here, and you want to extend it all the way to this location, right? And so in the mesh world, we call those hops, right? How many hops can a mesh network support? And in most cases, not just with Grandstream, but in most cases, you would not be able to go past 4 hops. And the reason for that is every time that you mesh one access point to the other, half of that bandwidth is used for the mesh connection, and the other half is used for the broadcast, right? And so these clients, let's just call him Bob. Let's say this main internet connection is 100 megabits per second, right? Bob, because of this mesh, he loses half of that capability. He can only get 50 megabits per second, right? And let's say you mesh this farther. This will access point C will only be able to utilize half of this bandwidth. So let's say Tim, that's connected here, will only be able to get 25 megabits per second, right? And then if you go one farther, ran out of names with DC, then only be able to get 12.5. So as you see, the farther hops you go, the less total bandwidth that is available. So typically, it's recommended to go no more than 4. 3, I would say, would be the best practices, because on the 4th hop, it's going to be very, very slow speeds. and not just the slow speeds, but the latency. So, you know, as you go farther away from this main access point, the wireless service degrades. Okay, but that was a good question. Okay. Deepak asks, is there any other way besides GWN Cloud that you can configure the 7602? Yes, you can also use GWN Manager, or you can use one of the other access points, one of the other model access points to configure the 7602. All right. And Asher says, oh, it means that I can use a 7630 and balance all 7602 in one network and make it work as a mesh. Absolutely, absolutely. Again, just keep in mind the limit for the 7630 is 50 access points with a local controller, and it's recommended not to go more than 4 hops. Okay. Akash asks, is there any distance limitation for bridge mode connection? The distance limitation is based on the maximum distance that each access point can send and receive, right? So typically in the bridge mode, people would use one of our long range access points, which is our 7630 LR that you see here, or the 7600 LR. I'll just kind of draw that out. That kind of looks like an access point, more like a resistor. I don't know. Now, these access points have a rating of 300 meters distance. And let me just take a minute to discuss this, because this is very important, right? We listed it on our data sheet as 300 meters. Obviously, in our testing, the devices have gone well above that. I've seen it go as far as 550 meters, but now that's in a direct line of sight, very little interference, and on a fair weather day. And so to be safe, 300 meters is the advertised distance. Now, in the wireless industry, for those that have done wireless for quite some time, you have undoubtedly heard of the infamous 1/3 rule, which means that any spec that you see for any access point, you cut that spec into 1/3 and use that as the real world deployment maximums, right? And so, yes, you can, bridge these at a 300 meter distance, and we've seen it done, and a lot of people have deployed it in 300 meter distances in the real world. But for the best possible performance and taking that 1/3 rule into account, it is generally the best practice to go a maximum of 100 meters. And I say that generally for best performance. And obviously, you can go 200, 250 without an issue, but it takes a lot of environmental factors to determine what your maximum distance is. Like if the two locations are in between a busy intersection, although they do have direct line of sight, where there's a lot of interference in the air, you're probably not going to get 300 meters. So it just depends in the full scenario. There's a lot of variables involved. But in terms of, technically, you can go up to the maximum distance that each access point has advertised. Okay. All right. Let's see. Deepak, how we configure mesh in case of 30 to 40 APs. The same way that you configure mesh in 4 APs, right? But again, as long as you keep in mind the 4 hop limit, right? You can design it like this, many different ways. So just depending on the situation, right? So, many different diagrams, but just keep in mind the 4-hop maximum, and you should be good. Yep. And just to confirm, Deepak, the 7630 LR and the 7600 LR has a 300-meter coverage range. Cool. That was a very lengthy explanation. So one of the differences between the 7630 LR and the 7600 LR is that the 7630 LR is our higher end outdoor long range. It's a 4x4 with a 2.33 gigabit throughput. The 7600 LR is a 2x2 with a 1.27 gigabit throughput. So those are the different. This is just some pictures of the mounting. All of the indoor access points, except for the 7602, come with ceiling mount attachments that will allow you to attach the access point to the ceilings. The 7600 LR and 7630 LR come with pole mounted options as well. So this is just some of the ways.
We are not able to see your presentation. We are seeing only your whiteboard. So
we
can only see your whiteboard.
Sorry,
yeah,
I
so
forgot
do that.
to switch it over. Okay. Now you can see.
Yeah, we can see that.
All right. Perfect. Yeah, so these are just, some of the mounting options that are available. And of course, this slide is just a comparison of all of the models. Obviously, it's probably very small, but don't worry, I'll send this presentation to everyone. But if you have access to Anita's Google Drive, all of this material is there so that you can use this as a comparison. And we do have some battle cards and cell sheets as well. It breaks everything down to make it a lot easier for you to understand what is what, so that you'll know what access point to use in what scenario. Whoops. I'm gonna skip all of this deployment scenario. I don't know why my PowerPoint is not updated. Okay. Now we go into the management options for our access points. Now we talked about GTECH Cloud, the embedded controller, and the GTECH Manager multiple times already, but I'll cover them in more detail in terms of why each of these would be used. All right. Now, what's unique about our access points is that all of them, except for the 7602, come with an embedded controller, which means that you do not need an external or a third-party controller in order to manage and configure all of your access points. Each of the access points can act as a standalone device. Now, again, all of them except for the 7602. Or you can use the access points to control other access points, which makes it a lot easier. Traditionally in a enterprise wireless topology, you would see the WLC, they call it WLC, or the wireless LAN controller, as a separate hardware entity on that topology. And that has been that way for quite some time. And then it has evolved into controller clients, or basically little pieces of software that you run on your PC in order to configure and manage your access points. And then it eventually evolved into the embedded controller, which we have. And these are really great because in a small deployment, typically anywhere from 30 to 50 access points, you wouldn't need that separate component into your network to make it more complex. Very easy. You keep everything in-house, so you don't have to worry about port forwarding and firewall rules in order to manage all of your access points. It makes it very easy. Now there are instances where you want to be able to manage more than, say, 50 access points. And this is where GWN Cloud comes into play. GWN Cloud is our cloud-based controller. It's completely free to use. There's no subscriptions, which is great. And right now we did put a limit on how many access points you can control, and that limit currently sits at 1 million. So hopefully that's going to be enough for most people. What's great about GWN Cloud, other than the fact that you can manage up to 1 million access points per account, but it also allows you to organize your networks so that if you were say, for example, a managed service provider or a system integrator that manages wireless networks for your customers, you can categorize each customer as their own network and even create sub-users with access to only their network. So you have a full remote management platform for all of your clients as well. And everything is on the cloud, so wherever you are that you have internet connection, you're able to log in, manage, and monitor your access points or your client's access points through here. A lot of times, the technical team knows, when the customer has a problem and you report that to us, Grandstream's going to ask for a trace. Typically without a cloud-based management system like GWN Cloud, you would have to travel to the customer's premises, capture the trace, come back to your office or your home and send that trace over to us. With GWN Cloud, you can do that from wherever you are, never have to go on premise. This makes it easy. So recently, we also released GWN. All right, I'll cover this in a little bit. We recently released GWN Manager, and what GWN Manager is this GWN Cloud on a software package that you can install on your local premises. As you guys know, with a lot of the video conferencing stuff that we've been working on together, there's a lot of enterprises, a lot of companies, even financial institutions that do not allow the use of cloud. Right? They prefer not to use a cloud solution because they want to have full control over their security and full control over their topology. And so we saw the need for that, and that's where GWN Manager comes into play. It's everything that's on GWN Cloud, but on a software package that you can install on your own hardware. I think I have some. Yeah, I do. Okay. So right now, the current limit for GWN Manager is 3,000 access points per instance. Obviously, we're going to increase that limit and let you determine your maximum based on your hardware. For example, I'm working or have deployed a solution in the Philippines not too long ago for 3,000 access points using GWN Manager, and now they're going through their second round of deployment, so they're adding another 3,000 access points. That makes 6,000 access points. And so what we've done is just remove that limit of 3,000 and let them upgrade their hardware so that it can support up to 10,000 access points. And as a minimum requirement for GTECH Manager, we have this listed. The software package that we provide is an RPM that can be installed in either CentOS 7 or Red Hat Linux 7 in the 64-bit variants. It won't work in the 32-bit because of the dependencies. As a minimum, we do recommend at least an Intel Core i3-3240. We recommend a minimum of 4 gigs of RAM. 8 to 16 would be best. We recommend a minimum of 250 gigabits of hard drive, and more depending on how much you want to store and save, depending on your records. And we do recommend an SSD over your traditional 3.5 or 2.5 inch spinning disk drives. Much faster in terms of accessing and writing data. So those are the minimum requirements. Keep in mind the operating system is very important. It must be CentOS 7 or Red Hat 7. I know that CentOS 8 and Red Hat 8 is out, but 7 is still considered the LTS, which is the long-term support version, which is the most stable version. Once CentOS 8 or even 9 becomes the LTS, then we'll upgrade our package to allow you to install that on those distributions as well. Now, with GTECH Cloud, for example, all of our devices are pre-programmed from the factory to contact GTECH Cloud by default. As soon as they boot up, they'll contact GTECH Cloud to make sure or to check if there is a configuration for it. So with GTECH Manager, it is a little bit different because it's not done as automatically as GTECH Cloud. There are a couple of ways. Number one, actually more than a couple, there are 4 ways that the GTECH Manager discovers your access points. One is if they're installed on the same network as the access point. If the access points are installed on the same network as GTECH Manager, it can automatically discover the access points via layer 2 broadcast. Same way that the embedded controller on the access points automatically discovers other access points in this network. The other 2 ways you can get your access points on GTECH Manager is to manually configure the manager address. First way, you can SSH into the access point and configure the manager address from there. The second is you can log into the web UI of each access point and configure the manager address. And lastly, the most preferred way for discovery, especially for access points that are not installed on the same network as GTECH Manager or local LAN as GTECH Manager, would be to utilize DHCP option 43. If you are in a network that needs to deploy GTECH Manager, more than likely you will have a router that allows you to configure DHCP option 66 for your IP telephony, as well as DHCP option 43. And from there, you just enter the GTECH Manager IP along with the management port, which by default is 10,014. And that way, as soon as access points boot up and get us DHCP information from your router, you can then send a query out to your GTECH Manager to be discovered. Now, I'm going to go back a couple of the slides real quick. Because with GTECH Cloud, as well as GTECH Manager, we do have the GWN.Cloud app that can be used on your mobile phone or your tablets. So we have both the Android as well as the iOS or the Apple version of this app in the respective app stores. This can be downloaded for free, and you can use this also to manage your access points instead of having to log into the web interface using a browser on a PC or a mobile device. Any questions so far? So that's all the product stuff. Just wanted to give everyone a refresh as well as introduce all of the new products that have recently been released. Because it's, as you can see, the portfolio is growing. We now have 8 different access points, as well as 3 different management tools. And you'll see that the portfolio is going to increase this year, especially with the adoption of Wi-Fi 6. And it looks like we're also, as an industry, is moving towards Wi-Fi 6E as well. But 6E will probably be a little bit slower to adopt because it uses the new 6 gigahertz frequency, and not every country has that frequency unlicensed. So for those countries, like say for example the U.S., where 6 gigahertz is unlicensed, 6E would probably be, I think, would, in my opinion, would be available as soon as the next generation iPhone comes out in September this year. But we'll see. Wi-Fi 6 will be our next lineup of access points. So keep an eye out for those. It'll be very exciting. Now, more on to the troubleshooting side of GWN. Let me take a quick drink of water, and we'll continue on. If you have any questions on what we've spoken about so far, feel free to ask, and we'll answer those.
Yeah,
before we move on.
you can hear me?
Mm-hmm.
Okay, I just wanted you guys, you can continue what I want. Every time we speak to our engineers, they say that they don't get, as per the data sheet, the access points go 100 meter or 300 meters, but they are not able to get the ranges more than 50 meters or 15 meters. So I want you guys to go into the configuration of the access point and tell them how to choose the channel, how to do it in auto mode or manual mode, or if you have coupons, the hotel coupons, the time-based coupons, all that high-end configuration, how you guys do it on the access point. I want this because all these guys, which you can see, except me, Rajesh, and Deepak, all are technical people, all are engineers. And I don't think so they would be knowing how to generate a hotel coupon or how to do a time-based internet access or how to freeze a channel on a specific access point where there's a lot of noise around, where a lot of access points of other makes are there. So how to go for manual channel selection. So I want you to just, as per your mind and your brain, you choose the typical configurations in the access point and explain them also. If possible, if it is okay to you.
Yeah, absolutely. I think, so this next section covers exactly all of that. Although I don't cover exactly how to configure, say, how to change a channel, because that's very easy and very simple to do. But I do cover when and why you would change channel, for example. I think that is probably more important than the actual configuration itself, because that part is the easiest part.
No, that's okay. I'm okay till these guys understand what you are trying to communicate, because I think, as per my experience, few of the guys would not be knowing also that we can actually go on the manual mode, because they just go to the site, plug the access point on, and job is over. They don't do anything else on that. So just put that focus on it. That's all my concern was.
Yeah, absolutely.
Okay.
So that's a great point. I think so. The focus of this next section actually is not on the access points itself, but on the actual deployment. Now with wireless, specifically wireless access points, it's quite different than what all of us are experienced with in terms of SIP wired networking, video conferencing, right? Because there are environmental factors involved, um, and we have to, in terms of wireless deployment, 90% of your time is going to be spent analyzing the environment and figuring out where to install your access points rather than the actual configuration. The actual configuration is done in the snap, but knowing what to configure when to configure each item is the most time consuming when it comes down to this particular industry. And that's what we'll cover today. So we'll go through a couple of things. Just give me 1 minute while I drink a bit of water. All right. So as I think everyone here can attest, troubleshooting Wi-Fi and networking in general is a different animal than troubleshooting, say, voice over IP. Right? Voice over IP is very easy. You do a Wireshark trace, and then you can figure out exactly what's going on. Wi-Fi, there's so many different variables involved, and we'll try to cover each of these. But what we've done on our access points to make it a little bit easier is have a physical mechanism, a visual mechanism for you to quickly gain the status of the access point, and that's through the LED patterns on the access point themselves. We have different statuses that mean different things. For example, blinking green in this table. It just means that the device is currently updating its firmware. A solid green means that the firmware update is successful. Let's see, you can move down to solid purple. When you see a purple light on the device, some people might panic and say, "What's going on here?" What that means is just that the unit is powered on successfully, but the unit has not been provisioned, meaning that it is not currently set as a master, and it is not currently tied to another master. So it's not configured, not provisioned. Blinking blue means that the access point is currently in the process of being provisioned, and solid blue that's the color that you're looking for. Solid blue means that the unit is successfully provisioned and has received its configuration, and everything is operating perfectly fine. So remember, solid blue is what you're looking for. So that's just some of the things that we use to make it a little bit easier. Now, based on Ashley's recommendations, let me get out of this presentation and let me load up a different presentation really quick, because I think it just covers a little bit more detail. And I do apologize if some of this information you guys know already, but I think it's very, very important that you do understand the fundamentals of radio frequency in order to be able to figure out and troubleshoot access points. So I'll cover this really, really quick. Actually, let's just figure out a way. I'm going to pick and choose from my other presentation that I made. And I'll start with some really basic wireless fundamentals that most people have learned in school but have probably forgotten. All right. Yeah. Now, when I mean basic, I'm going to go way back to electrical engineering 101. Right. So everyone knows wireless signals travel through the air in waves, right? As you can see in this picture, right? Now, in most cases, it travels in a uniform wave, right? And as you can see here, From one pattern to the end of the pattern, that is called a hertz, right? And
Are you there?
yep, yes.
If I'm not wrong, one crest and one trough is 1 hertz. No? If I'm not wrong,
One what?
one crest and one trough. The one full wave is 1 hertz, not the one which you are showing. If I'm not wrong.
No. That so what 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 you're probably thinking of is how many waves within a particular time frame, right? And that's where we're getting at.
Okay.
Right?
You go. Continue. You continue.
Yeah, yeah. And so we're talking about, oh yeah, the hertz, right? So you have that one wave within that 1 second. Now, time is also involved because in many cases, these waves move in a lot faster than in seconds, right? In milliseconds. And now you see here, you see that this where I listed it as a hertz, that's within 1 second, right? Now, if you have that same signal, 3 hertz within 1 second, right? That will tell you how many. That will determine the actual frequency of a wave. I think this is where Astaire was getting to, as you can see from there. Right now, in the real world, obviously, it have you especially in Wi-Fi, you hear the frequency of 2.4 megahertz or 5.0 gigahertz, 2.4 gigahertz or 5.0 gigahertz. What that means is within 1 second, this wave here, this wave pattern repeats 2.4 gigahertz or 2,400,000 times within that 1 second. Right, so it just happens very, very fast in a condensed amount of time. I think that's what you were saying, right, Esther?
Yes, you are right. Very right.
Yeah. Right, and so so that's what is called a frequency, which is a term that you'll often hear in Wi-Fi. Another term that you would hear is amplitude. And typically, amplitude refers to the height of the wave that you see. And to make it more relatable, that height is basically the power of that wave. Right? So obviously, the bigger the amplitude, the stronger the signal. So you'll hear that term quite often. And so the as the wireless waves travel through the air, it doesn't travel with the same amplitude and the same frequency throughout its lifetime. It's going to change, and in most cases, that signal is going to get weaker the farther it goes from the source of the signal. And basically, when a signal gets weaker or degrades, what we call that is attenuation. And there are many things that can cause attenuation, and we'll cover each one of these. Now, these are very important because this is what you will see in the real world all of the time. In those instances where Astor mentioned earlier, where you're getting weaker signal than what you're expecting, well, it's attenuation. And when you're deploying Wi-Fi, it's our job to figure out what's causing that attenuation. And so you have to understand the different types of attenuation that we experience in the real world. And these are 5 of the most common ones. Free path loss is a term. I guess it's a theoretical term because in the real world, it never exists. Basically, free path loss is the attenuation that a wave experience or a signal experiences as it travels through the air freely. As we know, especially these days, with a million different wireless devices, you're almost never going to experience a situation where there is nothing else in the air uh, that will change your signal. But that's what it's called. Free path loss is just the hypothetical attenuation that a signal undergoes as it travels through the air freely. Absorption is one of the main types of attenuation that we'll experience. And basically, what it is when a signal changes as it passes through material. Right here in this illustration, we have a signal passing through a wall, and depending on the material makeup of that wall, that signal is going to change, or in most cases, get weaker as it travels through that wall. And that's called absorption because the wall is absorbing an X amount of that signal. Right? And here's a list of some of the common, you know, I guess numbers that get absorbed through common materials that we experience on a day-to-day basis. Drywall, for example, not too much absorption, but you're still going to expect on average a loss of 3 decibels as the signal goes through drywall. For a hollow wood door, that's going to be 4 decibels. For brick walls, you're looking at about 6 decibels. Concrete, that's 100 millimeters thick. You're looking at about an 8 decibel loss. A refrigerator, you're looking at a loss of about 19 decibels. So depending on the material makeup of the obstacle that the signal has to go through, it will determine different signal degradations that you'll see. The other common type of attenuation that you'll see in the day-to-day basis is reflection and refraction. And yeah, a great example of this is our mirrors, right? Has anyone ever noticed? I don't know, maybe it's just me. I'm kind of weird, but I do use my mobile phone while I'm on the bathroom, right? But you ever notice that the signal is always weakest in the bathroom, right? And that's because of all the mirrors that are in the typical bathroom. That the wireless signal is just reflecting and refracting off of the mirrors, and it's going in different directions, and it's not traveling in a straight path in order to get to my cell phone from the access point. And so that's another very common type of signal degradation. Metal objects tend to also reflect the wireless signal as well. Okay. Obviously, as you guys seen from the Superman movies, lead will absorb the signal 100% of the time, because even Superman cannot see through lead, right? Another type well, another item that can cause a signal to degrade is noise. And it, basically, when you see, if you try to visualize a signal, right, as you see here, it's just a signal that goes from one point to the other in a wave fashion. If that signal collides with another signal that is completely opposite, it's a 180-degree opposite of itself, it will completely cancel out that signal. But it's a 1 in a million chance that you'll encounter a signal that is 100% opposite of your signal, but it comes very close. And the more signals that your particular signal that's in focus collides with, there's going to be more noise. And so with all of the hundreds and thousands of devices in a particular small area, you can imagine that there would be a lot of signals that are colliding with each other, causing a lot of noise. Some of these, you know, some of these origins of noise, it's not just other Wi-Fi devices, but just other devices that transmit radio frequencies, such as your traditional cordless phones, your old deck phones, your old analog cordless phones. A lot of them also use 2.4, so they can cause noise. You have your wireless audio systems, your nanny cams. Believe it or not, your microwave oven is a huge contributor to noise. And wireless security systems that don't necessarily use Wi-Fi, but just some other means of wireless communication. Just anything that, I guess you'd say the word pollutes the air, uh, is a form of noise. And so noise, it's a good time to move on over to the 2.4 gigahertz and 5 gigahertz channel comparison, because we get to see how much space we have to play with, and how much noise there is in each of these frequencies. Okay? With the 2.4 gigahertz frequency, right now there are, in most cases, 13 channels, in some cases 14 channels that are usable. But 13 channels in general, and each of these channels are 20 megahertz wide. However, of these 13 channels, there are only 3 non-overlapping channels, which means that channels that do not overlap with another channel, as you can see from this diagram. You have channel 1, 6, and 11. If you go back to the previous diagram, you see channel 2, 3, 4, and 5. They overlap with one of the other channels in one way or the other. 7, 8, 9, and 10 will overlap with each other. But only 1, 6, and 11 are clean, non-overlapping channels. Which means, I guess in layman's terms, these are the channels that typically have the strongest and cleanest signals. Now, 2.4 gigahertz. Actually, I don't know if you guys know this, but 5 gigahertz came out before 2.4 gigahertz. But because of the distance, it wasn't very popularly used because of the distance. Obviously, that has changed. Just a little bit of trivia. With a 5 gigahertz frequency, now you go from 3 non-overlapping channels now to 24 non-overlapping channels. So as you can see, the 5 gigahertz frequency is much wider, has a lot less chance of congestion because you just have so many more channels to use. So just a little table of comparison. The 2.4 gigahertz typically does have a greater range because the channels are smaller, but it does have a lot more interference. The 5 gigahertz channel does have lower range, but a lot less congestion. The channels are bigger. Typically, they're 40 megahertz channels, so you can carry more bandwidth on a 5 gigahertz frequency. So a couple of different ways that you can kind of see what channel is being used. Here is just one of the many tools that are available. I typically use Insider, but another popular tool is NetSpot or even acrylic Wi-Fi. These are all popular tools on the market that lets you scan the environment for the, I guess, the available wireless networks in that particular environment. As you can see here, this is just a scan that I did wherever I was at the time. And you can see the different wireless networks available, what channels they're on, how strong the signals are, et cetera, et cetera. And that is probably the first thing that you want to do when you go to deploy an access point is scan the environment and look at what's being used. In this case, you see that on the 2.4 gigahertz frequency, I see, well, these are my access points, but let's just say I want to install a new access point, and none of these are my access points. I see 3 access points, 3 wireless networks on channel 11. I see 2 on channel 6 and 1 on channel 8, right? So again, going back to the previous diagram on a 2.4 gigahertz,
So
yeah.
these channels you have selected manually in your house or in office, or it was on auto mode, it selected channel 6, which is non-overlapping.
Yeah, in this particular example, this is just a scan of the environment. So, these are the channels that the other access points are using, right? And so
Yeah, that's fine.
for
But like
myself,
for an example, for your own GWN Hue, I can see channel 11. Okay, so while you were configuring this access point, did you manually choose 11 intentionally, or it took on its own the non-overlapping channel?
in this particular case, it did it on its own. Our access points, when they first boot up, they run through an algorithm, and they'll scan the environment and select the best channel at that time. Yep.
Okay, fine.
Yeah. So in this particular case, it selected channel 11, and I think we're getting a little bit too deep to this, but if you look at the other channel 11s, you have LA, GWN, Wi-Fi soft. It has a signal of -77, which is very, very weak. And then you go down a little bit down more, and then you see the other LA, GWN, Wi-Fi that use channel 11. That's also -77. So those are very weak signals on channel 11. And so in this particular case, my access point picked channel 11 as well, because although there are 2 access points on channel 11 at a time, those are very weak signals. So it wouldn't necessarily interfere with my channel 11 as much. But if there's one thing that I can can teach anyone today, just from my experience in the networking world, um, I don't know. It's I guess in the Cisco world, there's a saying: if something is auto, you auto not do it. So in most
That's
cases,
a
if
good
there's
one.
anything that, yeah, if there's anything that you can do manually, do so. Don't let the dumb computer pick for you. So in most cases, like if this was a real case scenario, and these are other access points, and I want to install my access point here. After this scan, I see there are 3 access points on channel 11, 2 on channel 6. And knowing that the 2.4 gigahertz only has 3 non-overlapping channels, which is 1, 11, and 6, I would manually configure my access points to use channel 1, because there is going to be no interference there. Right?
Very
Does that
right.
make sense
It
for
should be
everybody?
one only. Yeah, it should.
Yeah.
Yeah.
Yeah. Okay. Cool. And in a lot of cases, you can actually get away with just using a Wi-Fi scanner like this and still have a successful deployment. And in many cases, it's fine. However, if you're going to deploy in a large area that requires multiple access points, you probably want to use additional tools, which we'll cover in a little bit later.
Can you
Okay.
also see the questions which Nitin is putting it on the chat window?
Oh yeah, sorry. Um, so Nitin asks, is there any tool to detect the number of APs will be used for an area or location? What is the site survey? Great question. So the tool that can help you determine how many access points to use in a particular location would be the heat map tool, which we'll cover in the later slide. So keep that in mind. And site survey is a term used to describe all of the things that you do before you deploy your access points. So typically, a site survey will include your wireless scan and your heat map. In some rare cases, you also have to use a spectrum analyzer, also, which I'll cover as well, because those are very important. And Nitin also asks, which signal DBM is good? Which is perfect because that's what my next slide is going to cover. So let me just go back one slide. Here, you see on this slide the signal. That's what everyone was looking at earlier. You see minus 38, minus 77, minus 43. These are the actual strength of the signals that are being detected from my laptop, right? Now, that's a good number to keep in mind, but the most important number is not that signal, but rather the RSSI, or the Received Signal Strength Indicator. And I listed here closer to 0 is better. And how you get this number is you take the noise, sorry, I'm talking about SNR. So RSSI is the Received Signal Strength Indicator. Um, as you see here, I mentioned earlier, this is the signal that is actually being received from my laptop, which is being measured from my laptop. It's not necessarily the signal that is being broadcasted from the access point, right? Because at the end of the day, what really matters is the signal that your devices are able to detect, right? And I listed closer to 0 is better because these numbers are always going to be negative. Um, if you are sitting, if your laptop is right next to your access point, you're probably going to get around minus 30 maximum. Sometimes you might get minus 29, minus 28, but minus 30 is probably what you're going to get because of the such things as the limitation of the antennas and how it travels through the electricity travels through the antenna and whatnot. But the closer you are to 0, the better that signal is. So again, I mentioned minus 77 is not a very good signal because I do have a list here of what is considered good signals and what is considered not good signals, right? So minus 30, I mentioned, amazing. You're probably right next to the access point, but you're not going to see that very much in the real world unless you're in a testing environment. Minus 67, I would say, would be the target signal for all of your deployments because it's a very good signal, great for streaming video, great for VoIP. You can pretty much do everything you can do with a minus 67 decibel signal. Minus 70, which is just an okay signal, great for email, browsing web, but probably not the best for streaming video. Now you go down to minus 80, that's not good at all. You're going to have a lot of packet loss. It's going to be very hard to watch your Netflix or your YouTube. And minus 90, it's unusable. Basically, you're right at the floor, and for a lot of access points, once you get lower than minus 90, that's a lot of access points don't even go to minus 90. That signal is going to be dropped. So these are some good benchmarks that hopefully answers Nitin's question. Okay. Nitin asks, if I configure RSSI manually at some values, then SSID goes on and off, what will be the best value to configure manually? So all of our access points have the feature where you can configure the minimum RSSI. And what that does is when a client goes past that minimum requirement, the access point will automatically kick them off of the wireless network. And what that's meant to do is it is meant to force the client to try to reconnect to a stronger signal, right? Because at the end of the day, the way that the protocol is set up, it is up to the client to choose when to disconnect and reconnect to a different access point or a different SSID. And so we have that feature there specifically for roaming purposes, right? And so when someone is moving from one location to the other, as they move farther away from the access point that they are connected to, um, in a properly set up roaming scenario, they would switch over to the new access point, um, when they still have a decent signal from the previous access point, so that they don't experience, your minus 80 dBm or your minus 90 dBm, where using the internet is not pleasurable. Right? So I think a good a good value to configure as a minimum RSSI obviously depends on the deployment, but I think about 78 and 79 would be the best. In some cases, you probably want to go lower if you want to ensure that the client always has a very good signal. You might choose to go as low as minus 71. Right? So it just depends on the scenario and what you're trying to achieve. Okay. So some tools here on Insider, it doesn't show you the RSSI, but if you look at sorry, not the RSSI, but the noise. In other tools like this one, this is the built-in Wi-Fi scanner on my Mac. Not only does it show the RSSI, but it also shows the noise. And so that's important because RSSI is a very good number, but it's not the most important number. The most important number is the SNR, which is the signal to noise ratio. Because even if you have a strong RSSI, if you have a lot of noise in that environment, that connection is not going to be as good as you think it would be. And so for SNR, or signal to noise ratio, you're looking for a value of around 20 or greater. And the way that this value is calculated is you take your RSSI minus the noise, and that's how you get the signal to noise ratio. So if you look at, let's say, the network here that is in bold, LAGWN Wi-Fi, you see that the RSSI is 50, and you see that the noise is 83, right? So SNR is calculated by taking RSSI minus the noise. So you get a minus 50 minus negative 83, which equals to, if my math is correct, positive 33. So you have an SNR of 33, which is greater than the 20 that is generally considered acceptable. So that's a good network to be on. But if you look at LA Lab 1, right, you have an RSSI of minus 70 and a noise of minus 83. So the SNR on that would be 13, which would be first off, a very horrible signal actually not very horrible, but not a good signal at -70 to begin with, and combine that with a lot of noise, that's gonna be a very horrible wireless network to connect to. Okay. All right, so let me get out of here because it covers a bunch of other stuff. Um, so a couple of things that you can do when you have, um, let's say you scan a network and you just see a bunch of um, 2.4 gigahertz channels, and there's really not a good channel for you to be on. One of the tools that we have on our access points is band stim. And as you guys know, the 5 gigahertz frequency in most cases is more desirable than the 2.4 gigahertz. And so with band steering, what we do is every time a client connects to our wireless access point, it'll go through a very quick determination. And based on the results of that determination, the access point will choose to have that device connected to the 2.4 gigahertz or the 5 gigahertz band. And this is just a little diagram of how that is determined. So as you can see, when a new client connects to the network, the access point will check to see if that client has 5 gigahertz capability. If it does, it'll put them on the 5 gigahertz frequency. If it doesn't, it'll put them on the 2.4 gigahertz frequency. And in most cases, you want to move as many devices over to the 5 gigahertz frequency as you can, because in this particular scenario, the 2.4 gigahertz frequency is congested. So just really quick, because a lot of times you're going to experience a drop in speed or a speed that is not desirable. And you just have to keep in mind some of the maximum data rates for the Wi-Fi standards that are available, right? Obviously, 802.11, 11B, and G, those are antiquated. You'll run into those devices or that standard less frequent these days. You'll run a lot into 802.11n, which has a maximum of 6 megabits per second, and 802.11ac, which typically maxes out at 1.3 gigs per second. The wave 3 of 802.11ac was supposed to go up to 6.7 gigs per second, but they decided to everyone decided to skip that and move on to 802.11ax, which is Wi-Fi 6 as you know it now. So just keep in mind these maximum data rates. That can help you. That'll save you a lot of headaches because you're looking at, oh, I'm on 2.4. How can I not get 1 gigabit per second? Well, 802.11n only goes 600 megabits per second, so you can't expect it to go more than that. And I say that because a lot of times, you're going to run into situations where you're not going to get the speed that you were expecting. And when that happens, we have several different tools available to us that can help us kind of troubleshoot why. Obviously, you're going to go through your Wi-Fi scanning, make sure that the channels are clean, make sure there's no interference. Then you're going to have to go to the individual clients and check to see what's going on. All right. In this particular case, it's just a random picture. of a Windows machine where there's a built-in tool, NetSH. You can use that tool to give you an idea of the network adapter that's installed on that machine. Most of the time, it ends up being the capabilities of the wireless client itself and not the access point. Right? Some of the older laptops, for example, have older network cards that one doesn't aren't powerful enough, and two aren't fast enough. If you look at some of the mini wireless 802.11n adapters, they have a maximum speed of 150 megabits per second. So you're thinking, oh, 802.11n, 600 megabits per second. Well, that adapter has a hardware limit of 150 megabits per second. So it's always good to look at the actual wireless client itself rather than trying to figure everything out on the access point. If you wanted to run throughput tests, JPerf is a really good tool. I think some of you that our team has worked with has recommended running some throughput tests using the JPerf tool. It really helps you just really measure the actual performance between two endpoints and the access point. So you can look at that. We can walk you through the whole process separately. Heat maps. We talked about a little bit about this earlier. This heat maps is, when you're working in a large area where you have to deploy multiple access points, heat maps is probably the most important tool that you can use for deployment. And basically, what a heat map is, for those that are not familiar, it's a tool where you can upload or draw the blueprint of a particular office or a building, like you see here in this diagram. And once you have that map, the floor map of the location that you're trying to install access points in, you can place your access point at a particular location and use this tool on, say, your laptop, for example, and walk around that location and measure the signal, and that'll be illustrated on your heat map tool. Right? In this case, you see, the reds are not good, the blues are great. You can walk around the whole building, the whole floor map, and measure the signal at every location. And from there, you can deduce how much attenuation is being experienced. Let's say there's a brick wall in between one of these locations, and you see that the other side of their brick wall, the signal is really, really weak, right? You'll be able to see that visually and then rearrange your access points to the best location. And in most cases, you'll end up having to add an additional access point. So yeah, Nitin, you're absolutely right. In this case, they would just need to add another access point from wherever they are.
So you consider the map which you are showing on the slide. So let's say this is a layout of a building, which now if I have to do a site survey, the engineer goes there, and salespeople always, tell them to go and do the site survey, that how many access points and what would be the right number of access points would be required to cover this in a perfect way. So do they have to manually change the location of access points at different point of the building to find the more of a blue area?
Yeah, absolutely. Because you're using your laptop to measure the signal from the access point. And so, first off, you're probably going to have to make an educated guess as where the access points would go first, right? And then from there, you're going to use this tool to confirm whether that's a good location or not, and then also determine if you're going to need more access points or not as well, based on the measurements. So let's say in this particular case, right? Let's say the access point was currently placed on the lower right-hand corner of this map. And, they're doing the measurements. The top right is great, it's blue, the middle is green, great. However, on the left there, it's red, but it's really not that far. So you'll probably notice that, oh, it's because of that brick wall that's there, right? And so no matter where you move the access point, it's still going to be red there, right? So in that case, you'll basically determine that you would have to put another access point in that room on the left.
Yeah. Have you done it personally sometime? Can we just upload the PDF layout or the AutoCAD layout directly on these tools?
Yeah, it depends on
Have
the
you done that?
program. Yeah,
Yeah.
absolutely. This is a program called NetSpot. Um, that's a free program. So it does allow you to upload PDF files, and it also allows you to draw your own maps. Um, you know, uh, what I've experienced is that a lot of companies and small businesses, they do not have a blueprint or a floor map. And so you do have to end up drawing it yourself. But a great tool for everyone to be aware of. These days on most mobile phones, like on my iPhone, there's a measuring app, right, that uses augmented reality. You basically use the camera on your phone to measure distance. Great tool to help you draw out your floor maps. Yeah, instead of
Can you just write it?
carrying.
Can you put it down on the? Can you also put it down on the chat window the exact names of these tools so that there is no confusion in terms of understanding the names?
Yeah, I think for the iPhone, it's just the measure tool that comes default.
No, I was talking about the site survey one, heat map one.
Oh,
Netscape
okay,
or
sure.
Netspace, you said. Yeah.
Yeah, absolutely. I'll just type in a couple of tools that I use
Yeah,
for,
that would be better.
yeah. Now the first tool that I'm typing in here is Insider, which is not a free app, but it's a very good app made by Geek. However, I know a lot of people don't want to pay so much money for an app. That one's $99. Another good one is Acrylic Wi-Fi. The one that you see here on the screen is a scanner and heat map, which is NetSpot. So those are some good ones.
Oh, thank you.
But yeah, I just want to reiterate that the heat map tool is probably, if not the most important tool that you should run uh, in every site survey before you actually install access point, especially in cases where you have to install multiple access points, like in this case, right? And lastly, so this is the Wi-Fi scanner, acrylic Wi-Fi that I mentioned in the chat. Just a Wi-Fi scanner, just like Insider, or even the built-in Wi-Fi scanner for Mac that I use. The last tool that I have that's very important is the Spectrum Analyzer. Now these are very different because they're specialized tools just for analyzing signals. Now, with all of these tools that I listed, Insider, Acrylic, NetSpot, they're all able to detect Wi-Fi signals, right? What they're not able to detect is non-Wi-Fi signals, like the microwave, for example. And so, you may, run these tools that I've listed and see that, hey, everything's clean, but how come I'm not getting a great signal? Well, it's very likely that there is some piece of equipment that's present um, that is wireless, but not Wi-Fi, that is interfering with your signal. And this is where the spectrum analyzers come into play. I'll give you an example. I helped deploy a wireless um, environment for a remote school in a remote village, and no matter what we did, um, we could not get a good signal on the 2.4 gigahertz, and we had to use 2.4 gigahertz because of the distance, and we just could not figure out what's going on until we went to the site with a spectrum analyzer, and it turned out that one of the generators that the school was using was emitting a radio frequency in the 2.4 gigahertz range that was interfering with the Wi-Fi. And none of our Wi-Fi tools was able to detect it because it's not a Wi-Fi signal. Uh, it, but it still was a radio frequency that was operating at or near the 2.4 gigahertz frequency that was causing interference with our Wi-Fi. And so we were able to figure that out and move things around, and we were able to successfully deploy Wi-Fi in that scenario. But if it weren't for the spectrum analyzer, we would not have been able to figure out that there was a a signal that was interfering, and B, the source of the signal, where that signal is coming from. And spectrum analyzers are very specialized tools. They do have portable spectrum analyzers that you can connect to your mobile phone, um, and use the app on your mobile phone to measure the result of the spectrum analyzer, or you can buy standalone spectrum analyzers to do the job. Hopefully, you don't have to run into this situation very often. But if you're, especially with Cohesive, as you guys do more and more wireless business, and you're working with integrators, on larger projects, it may be something to look into as an investment for the future. Cool. So I think that's the end of my slides here. Do you have any additional questions, guys? So let me just say real quick that, again, I just want to re-emphasize the fact that with Wi-Fi, it's completely different than voice over IP, video conferencing. I would even say surveillance, uh, in the fact that before you install anything, there's so much more work that is needed to be done before the actual deployment. The heat maps, the Wi-Fi scanning, the spectrum analyzing, that would take up about 90% of your time. The last 10% of the time would be spent on the actual installation and configuring of the access point. And I think, from my experience in the last 2 to 3 years, I see that a lot of people like us, like Cohesive and myself, um, that that weren't necessarily experts in Wi-Fi before, and now are doing Wi-Fi. That particular mentality was the hardest to understand. But I think once you understand it, once you go through a couple of successful installations based on doing the heat maps and site surveys and Wi-Fi scanning before the installations, I think everything will get a lot easier. Once you get a little bit of experience in there, it'll run through like a breeze, and you'll really become an expert in Wi-Fi. Wi-Fi is not that hard, so I think everyone here is capable of becoming experts. Well, feel free to ask your questions. I have a link up here on the screen. This is the quiz that I have for you guys. It hopefully the quiz would cover only the items that are relevant, right? So I didn't ask you, um, you know, what is the maximum throughput on the 7630 LR, for example. So feel free to visit this link. Let me see if I can type it in the chat as well, because Abhishek wanted me to explain MIMO. So I will do that while I post this link in the chat so that you can visit. Let me pull up my other presentation to explain MIMO real quick. Now, I do warn you that I made these animations on PowerPoint, and I'm not a PowerPoint expert by any means, so please pardon the animations. All right. So MIMO, obviously, you guys know the term that is very popular. Stands for multiple input and multiple output. And I think in order for you to understand what MIMO is, you really have to understand how Wi-Fi works in terms of message exchanges. So we'll start from there, right? So in a traditional wireless environment, wireless is a technology, what we call a half duplex technology. Just basically like your walkie-talkie, right? You can only speak. You have to push the button and speak, and then you have to let go of the button and listen in order for the other party to respond, right? So only one person can talk at a time. And that's exactly what Wi-Fi is. Till this day, it still operates like that. That's just the limitation of the technology. And so in a half duplex environment, this is kind of what it looks like in this animation. I hope it shows through. Right. So the wireless router would send a packet to the laptop, and the laptop would send one back. But they can never send it at the same time, right? Only one person can talk at a time. And in the beginning when they were first created, it was fine because they weren't exchanging huge amounts of data. But as Wi-Fi became more of a thing, more and more data is being sent. And so in order to increase capacity, what they did was add more antennas, right? So, we use one antenna to send, one antenna to receive. So as you can see, you're sort of increasing capacity at that point. But again, that's just how Wi-Fi works. It still works to this day. And so, they came up with MIMO now. There are two types of MIMOs. Let me go back. Let me go back one step. So this is, to increase capacity, we added antennas, right? So in the same scenario, if you have multiple users with a traditional wireless, this is kind of what it would look like. The router would send a packet to one client and then the next and then the next in a sort of a round robin fashion. It's more of a token fashion, but let's just call it a round robin fashion. So everyone takes turns receiving the signal, sending the signal. And so then now we go on to MIMO. There are two types of MIMO. In 802.11, well, I guess it kind of started in 802.11n, but it really became popular in 802.11 AC Wave 1. MIMO stands for multiple input and multiple output. Basically, what that means is that now the routers are able to send and receive multiple streams of data to a single client at the same time. Previously, in our previous animation, it was one by one, right? One antenna at a time. But with MIMO, as you can see from the animation, they can send multiple streams of data to a single client. And if you look at the same single user MIMO or first generation MIMO in a multiple client scenario, it still goes in a round robin fashion, serving one client at a time, taking turns, but each client is able to send and receive multiple streams of data. And so when you look at an access point and it lists just MIMO, there's no other, they don't put MU MIMO or SU MIMO. It typically means it's the first generation MIMO or single user MIMO. And that's how things are, in like in this particular scenario, that's how data is being passed. With MU MIMO, which is specific to 802.11 AC, wave 2 and above, the device is now able to send multiple streams of data to multiple devices at the same time. So let me repeat that animation, right? So as you can see with MU MIMO, you greatly increase the capacity of data that can be sent and received to all clients, therefore making everything faster. And that was my my explanation of MIMO that I made a very weird animation for. I hope that helped, guys. I hope that was clear enough.
Thank you very, very much for this small webinar. This is a WhatsApp number. My email IDs are there. The website addresses, you guys can reach us. Phone numbers, lines might not be working because of lockout, but you guys can write an email to us anytime.